Hello everyone and welcome to this lesson on the practice of past paper questions on the topic equations of motion SUVAT. This is your question number 1. We'll be taking up a lot more questions. One video will be covering one question. This is your video number 1 on question number 1. I'll show you the question. You can take a snapshot of the question, pause this video, try to attempt to solve the question yourself, then play the video again to look at the mark scheme and my working of this question. So this is your screen 1 of the question. This is your screen 2 of the question. Alright, take a snapshot, try to solve the question again, pause the video, and in the meanwhile do not forget to subscribe to the video if you are finding the videos on this channel really helpful, and I'm pretty sure that you would be finding the videos helpful. I'm trying to do my best, but if you still have any feedback, it can be a positive feedback which can be highly encouraging. If you have some suggestions on improvements, do just let me know in the comment box. It will be very helpful to improve the quality of the videos. Alright, so I hope you had paused the video and solved the question. Now you're coming back again. So let us understand how this question is solved. So let us start by understanding what the question is telling us. A trolley moves down the slope as is shown in the picture. So you have a slope, a trolley is moving down. The slope that makes an angle of 25 degrees with the horizontal is given to you. A constant resistive force Fr acts up the slope on the trolley. So let us mark this force where this force is. They are saying there is a constant resistive force. They have not marked it, but for our working purpose, let us mark it so that we do not forget it at any point of time in our calculation. So at time t is equal to 0, the trolley has a velocity of 0.5 meters per second down the slope. And at time t is equal to 4, the velocity is 12 meters per second down the slope. Now the first part of the question says, show that the acceleration of the trolley down the slope is approximately 3 meters per second square. So they are telling you to calculate the acceleration. We'll be starting with writing the formula for the acceleration. Acceleration is v minus u over t. This is the formula of the acceleration that we'll be using. Makes sense. Why should we be using this formula? Because you are given the two values of the velocity and the time difference. But the first thing we need to identify is which one is v and which one is u. So which of the velocity is u? The velocity which happened at an earlier point of time t is equal to 0 seconds occurs earlier, and the velocity was 0.5. The time which came later was 4th second. So at the 4th second the velocity was 12. So you are sorted, you know what is u, what is v. Let us substitute the values. V is 12 minus 0.5, and the time taken for this entire change is 4 minus 0, which is 4. So 11.5 divided by 4. You can solve this and you would see that it is approximately, it will come out to be 3 point something, but when you round it up, this whole number is approximately 3 meters per second square. Let us tally with the mark scheme as well. I believe it in showing the mark scheme at every point of time so that you understand what Cambridge expects you to write in your answers. Again, see, the Cambridge expects you to write the formula as we have done already. Cambridge expects you to identify the value of v and u correctly, input the values correctly in the formula, and if you see, it is 2.9 or approximately 3 meters per second square. Alright. So whenever I show the mark scheme, you may also wish to pause the screen at the mark scheme, read the mark scheme properly, and try to understand the mark scheme as well. When you're solving the past paper question, it is always a good idea to go and read the mark scheme working very nicely. It helps you understand how to write your answers. Now the second part, calculate the distance x moved by the trolley down the slope from t is equal to 0 to t is equal to 5 seconds. You know the acceleration, which is approximately 3. You know acceleration, you know U, you know V, you know also T. T is 4. You have to find distance x, which is same as displacement s here. Alright, so what are the formulas for the displacement that you know of in SUVAT set of equations of motion? You know A, U, V and T. Please do make a note, and you have to find S. Let us see which formula can we use. Here you have the equations of motions of SUVAT. You need not memorize these equations. Please do understand these equations will be given to you in your question paper in the list of the formulas attachment that comes along with the question paper. So which formulas make sense? Looks like the formula 1 makes sense. You know U, you know V, you know T. Even the formula 2 makes sense. You know U, you know T, you know acceleration as well. Even the formula 3 makes sense. You have S here, you have to find S. You know V, U and acceleration. All the 3 formula make sense. You can choose any of the formula, believe me, and you should be getting the same answer. You can try it out yourself. You can use each of the formula one by one in your practice time, and you'll be surprised to see that each of the formula will give you the same answer. So let us work it out with equation number 2, which seems to be the easiest. Okay, so which is U plus V over 2 multiplied by T, which is same as average velocity. You're finding the average of the initial and the earlier velocity, initial and the final velocity, and multiplying it with the time. You can do this way, and you'll find the value of the distance. Substitute the values. So 0.5 plus 12 by 2 into time is 4. So it becomes 12.5 times 2, so it becomes 25. Let us tally our answer. 25. They have also used the easiest equation, if you see. But your wish, in the examination, whichever formula comes in your mind first, whichever formula you're convenient with, you can work with that. Do not worry about it so much. Second part, sketch the variation with the time t of the displacement x moved by the trolley. Displacement x moved by the trolley. At time t is equal to 4, how much is the displacement? 25. At least this much you know. Let us mark 25 anywhere. At time t is equal to 4, the displacement is how much? 25. At least this point you know. 4, 25. Right? So what is happening here? Is it an acceleration? You know it is an acceleration, and that too acceleration is a positive value. So you are very well aware that there is no deceleration. No negative value, that means it is a perfect clear case of acceleration. So how do you depict acceleration on a distance time graph? Go through my video or the theory on the motions on distance time graph, speed time graph. You'll understand how to depict acceleration on a distance time graph. It is an upward going curve. All that you have to do is to draw an upward going curve like this. The upward going curve can be like this. It has to be upward going curve, or like this, whichever way you wish to draw, but take care that it is an upward going curve. Any which ways, any of the lines, doesn't matter what is the curvature. Starting point should be 0, 0, because it was very clearly mentioned that it starts time 0. It starts, right? So like this. Initially also it had a velocity, right? So it means that you should not have any flat section initially. Do not have any flat section. Everything should be an upward going curve. All right. Second, now the mass of the trolley is given to you. Show that the component of the weight of the trolley down the slope is given is a 8.3 newtons. Component of the weight of the trolley down the slope. Let us understand from this. So how much is the weight vertically down? Weight vertically down would be, Weight vertically down would be mg. The formula for weight is mg. They are saying the component of the weight down the slope. They are telling you to find the component this way, right? So what is the component? This is W sine of 25. Sine of 25. Alright, so how to find the components of the vectors? Please do go through it. You'll understand it. You'll understand it in the theory that I've explained in my videos. Then you'll understand. So it should be W sine 25. So W sine 25 degrees. W is how much? mg. W we know is mg. So substitute the values. 2 times 9.81 times sine 25. Alright, they should give you your answer. Let us tally with the mark scheme. Yes, sine 25, 9.81, mass was 2. Everything is the same and you should get your answer, which is 8.3. 8.3. Newton's weight is a force. Please do understand. Go through my theory on the weight if you do not understand what is weight. Weight is a force, Newton's. Right? Calculate the resistive force Fr. What is the resistive force? Let me bring the diagram for this question on this screen and then we'll attempt it. Okay, so now I have got the diagram on the same page. Calculate the resistive force. Where is the resistive force? As I had marked it earlier as well, but somehow it got erased. The resistive force is in the backward direction like this. Fr. Why did I take care to mark the resistive force as a smaller arrow as compared to the weight downwards, which is a bigger arrow? Why? Because the trolley is ultimately moving down. The movement happens in the direction of the bigger force. So deliberately I took Fr to be smaller as compared to the bigger downward force, which is the component of the weight. Be careful about all these small tiny things. It improves your understanding. Motion is happening downwards. That means the bigger force should be downward towards the inclination of this slope. Alright, calculate the resistive force. Easy question. The only formula that you need to use here is F is equal to ma. What is F? F is the resultant force. F is equal to, in the equation F is equal to ma. Please do remember this F is always the resultant force. Resultant force. This is something that I tell my students again and again. In the formula F is equal to ma, F is what? F is not any of the individual forces. It is the resultant of all the forces acting on the object. So what is the resultant force acting on this object? On this trolley? What is the resultant force? It is W sine 25, which is downwards, minus resistive force. W sine 25 we have already calculated, which is 8.3 minus Fr. This force, which is 8.3 newtons, minus Fr. Why minus? Because they are in the opposite direction, so you subtract them to find the resultant force. Let us input the values in the equation now. So what is F? 8.3 minus Fr. Mass is how much? 2. And acceleration is how much? We have already calculated it in the previous question. How much was the acceleration? 3. The acceleration was 3. So let us take this value into 3. So how much is the resistive force? 8.3 minus 6, which is 2.3 newtons, and this should be your answer. Let us tally with the mark scheme. Yes, they are taking acceleration not as 3, right? They are taking it as 2.9. If you are working with 2.9, you will get the value of the resistive force as 2.3, but 2.3, whatever we have done is also correct. 2.3, if the acceleration is 3, is also correct. If you are using acceleration as 2.9, you'll get the answer as 2.5. Right, so this was your mark scheme. You can pause the mark scheme, understand it, and all this question was based on your equations of motion. The next question again will be on the equations of motion. Stay connected.